So we know we study theory of computation to understand the limitations of computing. What kinds of problems can a computer solve and what can it not solve? Two key concepts in theory of computation to help us answer this question are the string and the language. And to know how exactly strings and languages will help us understand computing, we need to know what they are first. And that is what we will be discussing in this video. If you have written programs before, you have probably come across a string. They are usually a sequence of any symbols put between quotation marks, such as this string with Latin letters, this string with integers, and this string made up of smiley faces. And of course, there is also the empty string. In theory of computation, strings work exactly the same way, but these quotation marks won't be necessary. The empty string is also represented with this symbol, which we call the epsilon. Knowing what strings are, we can now construct languages, which are just sets of strings. You can think of a set like a container that you can take things in and out from, and a set of strings would be like a container of strings. So this is an example of a set of strings, and this is another example of a set of strings, and we call both of these sets languages. And for any string in each set, we say the string is in the language. So for this language, we can see that 10 is in the language and 001 is in the language, but 1 is not in the language, and neither is 010 nor 0001. One more important thing to know about languages is that we can perform operations on them. Similar to how addition, subtraction, multiplication, and division are operations we perform on integers, there are operations we can perform on languages. As examples, we'll use these two languages, A, which contains the strings mango and orange, and B, containing the strings green and orange. The first operation we will look at is union, represented by this symbol. The union of two languages A and B will give us a new language containing any string that is either in A or in B, and there will be no repeating strings in this new language. So even though green is not in A, it is in A union B. Another operation we can perform on languages is intersection. The intersection of two languages A and B will give us a language containing strings found in both languages A and B. So, since orange is the only string that is in A and also in B, then orange is the only string that we would find in the intersection of A and B. The third operation we will look at is a little different, and that is concatenation. When we concatenate A and B, we get a language containing strings that start with a string in A and end with a string in B. So the concatenation of our A and B languages here will give us mango green, mango orange, orange green, and orange orange. Note here that mango green is in the language of A concatenate B, but green mango is not. Green mango is instead in B concatenated with A. So be sure that you notice this difference. And finally, there is the star operation, which is applied on only one language instead of two languages. And what the star operation does is attach together strings in the language 0 or more times. So for example, A star will give us orange, mango, orange, 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 mango, mango, orange, mango, mango, orange, 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 mango, orange, and so on. Because we can attach the strings any number of times, the resulting language is an infinite set. And because we can also attach the string 0 times, the empty string is always going to be in the resulting language of a star operation as well. It's good to pause here for a bit and to think about which strings would belong in certain languages and which would not. Like orange is in both languages A and B, A union B, A intersection B, A star, but it is not in A concatenate B. Orange orange, however, is not in languages A, B, A union B, A intersection B, but it is in A concatenate B and A star. and orange, orange, orange is only in A star. So be sure that you understand how there are differences between the languages that result from operations, but there are some overlaps too. At this point, you might be wondering, why do we call them languages when they are really just sets? Well, languages are to sets as footprints are to holes, since footprints are essentially just really useful holes that tell us a little bit more about the world. And in this same sense, we will be using languages to better understand computing. And now that we know what strings and languages are, we can finally start constructing machines to do so.